Hello everyone, myself Sagar Ramesh Kutte, working as Assistant Professor, Department of Physics, GMD College, Sinnar, Nasik. Now, last lecture we will discuss module first, and this lecture we will discuss module second on topic molecular orbital method and valence band method. First will be the molecular orbital method. In the molecular orbital method, acceptable molecular wave function called molecular orbit and discrete molecular energy state are derived first. These molecular orbit extend and embrace all nuclei in it and will be polycentric. They have the same significance as do atomic orbital. Molecular quantum number are associated with this orbital. Once the molecular orbit are obtained, the system of electrons are built up by the filling the orbital with electron in accordance with Pauli's exclusion principle. The problem of MO theory, that is molecular orbital theory, is therefore the construct reasonable molecular orbit. This can be done in number of ways. As molecular consists of atom, molecular orbital may be taken as functional of atomic orbital center on the individual atom. The most commonly used approach the obtaining the MO of their linear combination of atomic orbital as Lco approximation. In this approach, the molecular orbital psi is written as linear combination of atomic orbital, that is psi is equal to C1 psi1 plus C2 psi2 up to H dash, where psi1 and psi2 are individual atomic orbital. The constant C1 and C2 are to be selected in such way that energy gives psi is minimum. To generate effective molecular orbit by the Lco method is combining atomic orbital must have first energies of comparable magnitude, second considerable overlapping, and third will be the same symmetry. If the orbital have different energy, the electron will be remain most of the time atomic orbital which has the lowest energy. As the first example, we shall consider the molecular orbital of hydrogen ion. This will be the theory of molecular orbital method. Now second will be the valence band. Valence band, Hilter and London were the first apply quantum mechanics to valency problem in 1927 by giving the quantum mechanical treatment of hydrogen molecule. Their idea were lateral extent by the Salter and Pauling to give the general theory of chemical bonding, and the theory is known as valence band method or Hilter and London and Pauling's method. In these approaches, atoms are assumed to maintain their individual identity in molecule and to be arises due to interaction of valence electron. When the atom come closer, it amount the considering molecule component of atomic cores and bonding valence electron. In the words valence band method, considering beginning the atom with their associated electron together, allowing them interact to form the bond and thereby the molecule. This will be the theory of valence band method. Now next topic is rotational spectra of rigid diatomic molecule. A diatomic molecule may be considered as a rigid rotor consist of atomic masses m1 and m2 connected by the rigid bond of the length r. Consider the rotation of this rigid rotor about axis perpendicular to molecular axis of passing through the center of gravity. The solution of Schrödinger equation for the rigid rotor gives the energy eigenvalue will be Ej is equal to h cross upon 2i into j bracket j plus 1 joules. J is equal to 0, 1, 2. J is the rotational quantum number and each level is 2j plus 1 fold degenerate. I is the moment of inertia of molecule about the axis passing through the center of gravity G and perpendicular to the molecular axis. This will be the diagram of rigid diatomic molecule. I is equal to m1 r1 square plus m2 r2 square. m1 r1 is equal to m2 r2. R is equal to r1 plus r2. Expressing r1 and r2 in term of r and substituting in above equation, we will get r1 is equal to m2r upon m1 plus m2 and r2 is equal to m1r upon m1 plus m2. I is equal to m1 m2 upon m1 plus m2. R square is equal to mu r square, where mu is equal to m1 m2 upon m1 plus m2. Often it is convenient to analyze the rotational energy spectrum in wavelength unit. Therefore, we may be right. Ej is equal to Ej upon Hc is equal to 8 pi square Ic into j bracket j plus 1 bracket complete centimeter inverse is equal to Bj bracket j plus 1 centimeter inverse, where B is the rotational constant and is given by, that is this B is given by B is equal to h upon 8 pi square Ic is equal to h square upon 8 pi square I, denoting the lower state J double dash and upper state J dash. Delta Ej is equal to Ej dash minus Ej double dash is equal to B bracket J dash plus 1 bracket complete minus J double dash bracket J double dash plus 1. Use of selection rule, delta J is equal to plus 1, that is J dash minus J double dash is equal to 1, gives the frequency of absorption line as V bar J is equal to delta Ej is equal to B bracket J double dash plus 1 bracket complete second bracket J double dash plus 2 bracket complete minus J double dash bracket J dash plus 1. V bar J is equal to 2B bracket J plus 1. J is equal to 0, 1, 2, 3. The rotational constant B is assumed to be same in the both lower and upper rotational state, and double prime is dropped from this above equation J and above equation J value of lower state. Now this diagram indicates that the rotational energy level and transition for rigid diatomic molecule. Thus the series of spectral line with the wave number value 2b, 4b, 6b is expected for the rotational spectrum of a rigid diatomic molecule. The separation between any two adjacent line is 2b, as the rotational level are closely spaced. Compare with KT. Many of the lower level will be responsible population leading in spectrum with the sufficient line. K is the Boltzmann constant. The energy level and the allowed transition as shown systematically in this figure. The value of B can be deducted from the spacing between the observed spectral line. The intermediately give the internuclear distance of the diatomic molecule. This will be the theory of rotational spectra of rigid diatomic molecule. Now in this lecture we will discuss molecular orbital method, second will be the valence band method, and third will be the rotational spectra of rigid diatomic molecule. Thank you so much.